Thank you everyone for joining. Welcome to our webinar. So this is we're going to introduce our research theme, and the broad topic today is climate change, sustainability and cities. And just to introduce you to our institute, so we are the Institute for Environmental Design and Engineering at UCL. This is our building in North London or Central London. We have around 130 staff and doctoral researchers, and we have 8 research themes. So this is our theme meeting today. And the reason we're having this event is that environmental design and engineering research is celebrating its 60th anniversary at UCL, and we're marking this with a number of events like this webinar. We have a full day in-person event in October, and we also have a book coming out. Just to introduce the research themes. So this is the list of themes, and you can see highlighted is the one we're talking about today, which is climate change, sustainability and cities. And I should introduce myself because I am the research theme lead for this theme. So my name's Claire Heaviside and I'm an associate professor at UCL. And I also like to introduce Charles. Maybe he can introduce himself as well.
Hi, I'm Charles Simpson. I'm a senior research fellow at IED. So today we're going to be talking about our theme, climate change, sustainability in cities. This interacts with a lot of the other themes that are covered in environmental design and engineering. And so we want to address complex interlinkages between cities, urban climate, climate change, health and sustainability. And so some examples of work at our institute in this theme include quantifying impacts of climate change on health, evaluating the impact of climate change mitigation and adaptation pathways, and investigating ways to reduce urban environmental risks and inequalities. So really looking forward to hearing from our speakers today. Thanks, Claire.
Thank you, Charles. So yes, today we have 3 fantastic speakers. I'm very happy. They're going to cover a kind of broad overview and also some more details about their particular focus areas. So to introduce the 3, we have Professor Sotiris Vardalakis, who's from the University of Canberra, and he's the director of Healthy Environments and Lives National Research Network and Professor of Environmental Public Health. We also have Professor Marialena Nikolopoulou from the University of Kent, and Marialena is Professor of Sustainable Architecture. And we also have Professor Gerald Mills, who is Professor of Physical Geography at University College Dublin, and he also holds the Luke Howard Award for his lifetime achievements in urban climate science. So what we'll do is we'll kick off with Gerald, who will give an overview, and then we'll have the other 2 speakers, and then we'll have time for some Q&A at the end.
Hello, everybody. Thank you, Claire. Thank you, Charles, for inviting me to present. My name is Gerald Mills. I'm based in Dublin, and the focus of most of my research is on the climate of cities. So I was asked to give a perspective on the development of urban climate science. And I think the reason why I'm first is to try and put some of these things into context. It's actually quite a big field because, as you would have heard, it talks about sustainability, which means linking climate to other issues outside the normal scope of climate science, about its linkages to things like impacts on heat, on health inside cities. So what I'm going to do is provide a broad understanding as to what the urban climate science is about and where I think it's going and where I think it needs to go. I'll talk about advances, but I'll also identify clear gaps that I think we need to take on. So, cities, we now know, of course, occupy a tiny proportion of the landscape of the world, probably less than 3%. Yet they are host to more than half the population of the planet, and that's likely to continue. So if you think about it, then most of our science is not really set up at a global scale to look at cities, simply because they're quite small. The flip side of this, of course, is that all the actions, all the activities associated with humans are all concentrated inside cities. So if I want to understand climate change, I have to be able to understand cities. but the systems we set up to look at global climate change aren't really a good fit for the scale at which the problem arises. If I was to take all the big cities in the world and look at what types of climates they occupy, here's a distribution of the cities. The colors in each of the bars represent the populations inside each of those different types of climate zones. And it's a very, very simple classification here. A is tropical, which is red. B is arid, which is sort of yellowy. And the green is temperate. What's missing here, sorry, is D, which is the cold climates. So most people actually occupy either A climates or C climates. And that's where you find most big cities. By the way, we know very little about most of the climates in most tropical cities. Much of the work that we know about comes from the C-type climates and not from the A climates, yet the A climates are the places where the cities are going to emerge in the future. How is it linked to sustainability? Well, simply the fact that urban areas are enormous black holes when it comes to consuming resources. And that means they're also places where you get enormous amounts of waste generated. That's solid waste, liquid waste, and of course, airborne waste. So if I want to understand the anthropogenic effects on the planet, again, I have to go back to cities themselves. So let me talk about the foundations of urban climate science. And it's not a global perspective, it's just the opposite. It's a city-based perspective because that is the beginning of urban climate science. In fact, we normally refer to it as urban climatology. And the idea behind it was that you'd look at the urban effect on climate. And that effect on climate was most easily observable at the scale of the city itself. So the best known example of this, of course, is the urban heat island. Now, I'd like you just to think for a moment about what this science tried to do. It tried to isolate out the effect of the city on the climate where the city was based. And the way it did this was taking the climate outside the city as a background climate. So if I compared what I was measuring inside the city against that outside the city, I'd be able to determine specifically the urban effect. And I'd say that has been the basis of studying the climate inside cities for the past 200 years. Fundamentally, description is the first part of it. The other part is to understand it. So the understanding came down to trying to understand the relationship between aspects of urban form and functions and how they drive that urban effect. But here's the thing. We largely took the background climate as fixed and not changing. So the idea was that we'd identify the climate effects inside cities. So it's a very long established science. We're going right back to the first scientific exploration of the climate inside cities, which is by, of course, Luke Howard, the person who classified the clouds and was a Londoner himself. And if you look at the methodology used, which is back in the 1820s, and before that, he took measurements in what he referred to as the countryside around London and compared those to measurements made inside the city itself. And he discovered an urban heat island. Now, here's the thing. He wasn't interested in the urban heat island. He was interested in the climate where the city was located. So we regarded then the measurements inside the city as a sort of contamination because he was interested in the climate of where the city was located. And by this simple measurement, he managed to discover there was actually an urban heat island. Urban climate change are absolutely profound, extreme microclimate variation. We're going to hear about enhanced heat stress inside cities, largely because cities are barren. For the most part, they don't have a great deal of vegetation. Extraordinary changes to the hydrology. Much of the river systems are now gone and placed underground. And of course, poor air quality. Now, I can attribute all these outcomes to what I'm going to call the two attributes of cities, which vary over space. The first is aspects of the physical form of the city. We would have an urban climate even if everybody left, simply because we've removed vegetation and replaced it with impermeable surface cover. That surface cover has got extraordinary, unusual characteristics in terms of thermal radiation characteristics. We've created 3D objects and we've arranged those objects to create very distinctive geometries. And these are aspects of form. And of course, they also have aspects of function, such as, for example, the mobility associated with traffic and all the emissions associated with it. The buildings themselves, which might be used as warehouses, might be used as commercial and are occupied during the day, and there might be residences. And then in many cities, there still is a strong contribution from manufacturing and industry. So these are the functions. And we know that the forms and the functions are very strongly correlated to each other. one of the big achievements in the field is to understand those climate effects and place them into scales. And I think this is the most important thing that you can take out of the study of urban climate. If you want to understand the urban climate, you better be very, very careful describing what type of climate you're talking about and the scale at which it operates. So this model, dividing out the types of climates in cities into whether it occurs at the city scale, which is mesoscale at the top, whether it occurs at the neighborhood scale, which is on the lower left, or whether it occurs at the micro scale, is critical to how you actually understand climates inside cities and how they form. And what we've done over the last 50 years is try to isolate those different things by just simply building a fake city and pulling out the elements and trying to understand what's happening, or placing instruments inside streets and placing instruments at different heights to capture those different types of urban effects. Okay, here's the flip side of it now, which is only just emerging really, which is the integration of what's happening inside cities with global climate science. So I would have said that global climate science was largely focused on trying to understand, obviously, the Earth's climate. So we've moved from talking about, for example, global climate models to talking about Earth systems models. And since the 1970s, there's been a big effort to try and distinguish between the anthropogenic and the natural causes of climate changes. And we know that the main driver of climate change, which is anthropogenic, is associated with the emission of greenhouse gases, which is associated with functions. Now, there's another part of it which is associated with changes in the changes in the landscape across the planet. But the primary driver of climate change at a global scale are greenhouse gases. So that science is based upon understanding, models, and then observations, what you'd expect out of any science. Here's the thing. Because of the technology, because of the approach taken to look at Earth climate science, cities aren't included in those models. Not directly. So we have the missions in the models, but we don't actually have the cities themselves, largely because of their sizes. And then, in alliance with what I've just told you about the urban climate itself, global climate science has largely ignored cities, and they don't make any measurements inside them. So if you think about this, we want to know about the climate from the point of view of human beings, and we studiously avoid making measurements in the place that we live. So here's the idea. Urban areas directly affect the climate at the scale at which we live, but they also contribute significantly to the change in global climate, which means that many of the hazards that we're going to face in the future are the direct product of emissions that we made now, which are concentrated inside cities. So if I take this idea of the city climate, the background climate, then the net effect of cities overall is to change the background climate, which will affect the city itself. So we need an integrated climate science that can adjust or cope with changes that happen at a micro scale, at a street scale, at a city scale, and also cope with understanding about what's happening at a global scale. This, of course, is the famous Keeling curve. It talks about greenhouse gas emissions, greenhouse gas concentrations, in particular CO2. But if I was to look at this spatially, I'd find that most of the greenhouse gases are coming from very, very distinct parts of the world, mostly from the developed world and mostly from the major concentrations of population in the developed world, which of course are in cities. So that's where the responsibility comes for things like, for example, mitigating greenhouse gas emissions. If I look at the populations are also concentrated inside cities. This is where the exposure is. So the mismatch between the two is an indication of the extent to which some people located in developed world cities are generating the problem, and the extent to which other people located in poor cities outside the developed world, economically developed world, are going to suffer the consequences. So where has this got to go? Well, it's got to go, I think, toward some form of integrated, multi-scale climate science, where we actually have knowledge that is actually applicable at the scale at which we want to make changes. Here's my broad timeline of the development of the field. And it's only at the very, very end you start to see these two climate sciences, one at a city scale, one at a global scale, start to come together. And it's still at the very beginning phase of this, I think. What would we want out of such a science? Well, we need the infrastructure. And fortunately, in the past, because we've avoided city, I think that we've been late to the game in trying to come up with a infrastructure that can cope with changes over different scales. Clearly, we need a form of exchanging the knowledge that we have. And that means we have to agree on terms so we can actually have a discussion. And the key part, which I think is the weakest part of our science at the moment, is applications and then evaluation of the applications themselves. And this varies based upon where you're located. So I would say that one of the major claims of science is the potential for knowledge transfer into different fields, into different areas. And it seems to me that the weakest part of our field is our inability to actually convert what we know about how cities change climate into changing the development of the new cities on the planet, which are mostly outside of Europe and North America. So we do know an awful lot about urban climate, and we do know how to adjust it. And there are very, very strong connections between urban planning and urban design and issues like climate change. So here's a perfect example of a beautiful piece of design, I think, in the city of Nîmes in France. You could describe it as trying to address climate change or change inside cities, or simply to make the place more pleasant, which uses effectively grass and trees to provide evaporative cooling. It has a water feature. It's got shade. In other words, I'd regard this as a lovely piece of adaptation and mitigation. Now, it only works, by the way, because the effect of that is largely confined to the area where you see all these features. It only works if people know about it and if it's accessible to the local population so they can use it. So let me finish off by what I think will happen next. I think there's a whole bunch of stuff that the field needs to do. It needs to integrate not just global climate science with what's happening inside cities. I think we need to start to integrate what's happening inside buildings, what's happening outdoor, that we need to start integrating what's happening inside streets up to the level of cities. Let me take the big one. What's the best way by which you might be able to integrate what's happening inside cities with global climate change? I think it's going to take some fundamental rethinking about how we structure our global climate science. So if I take observations as the part of the infrastructure, the other side of that are the models themselves. And the conventional models are established on a grid-based system. So blocks of landscape are given the same amount of concern, no matter whether they're over the Pacific Ocean or whether they're over London. And I think it's going to take a reconstruction of our understanding of how to best model global climate using, for example, things like variable grids, where we have different grid sizes depending on where people live. It's very complex because that means effectively reorienting our knowledge system over the last 70 years. But I think if we're going to have a genuinely integrated, multi-scale understanding of cities, global climate change, and urban effects, that's what's going to be required. So I will leave it there. Thank you. That's just my perspective on where the field is and where it's going to go next.
Thank you very much, Gerald. That was excellent. Great to kick off. So maybe now can I invite Marialena to share?
Thank you very much, Claire. Good morning, everybody. It's a pleasure to be here today. And thank you, Gerald, for providing this wonderful introduction of some of the key issues and how sort of the wider of the built environment, sort of architecture and urban design fit within this wider system. So I'm going to look at it from sort of the architecture perspective mostly, with quite a wide title. So just to highlight the problem and really addressing this sort of a phenomenon that we're actually, most of Europe has been going through in the last couple of weeks with heat waves everywhere. So really reducing sort of urban heat becomes a big priority for most of the world at the moment. There was a really interesting article at the National Geographic sort of 3-4 years ago, which highlighted not only the issue around heat, but the equity dimension as well. Specifically, that article was looking at the city of Los Angeles and highlighting how 20% of the city's trees are really in 1% of the city's population, where the richer areas have wider canopy, providing the evaporative transpiration, the cooling, the shading, whereas the poorest neighborhoods, which you who would argue really need the shade. They don't have the extensive air conditioning, have less than 10% of the area. And very frequently the discussion we hear, oh, you know, this is the States, they design differently. In Europe, we're much more sort of focused on proper urban design. We address some of these issues better. Where are we actually addressing them? There was a really interesting article at Nature Cities last year, really highlighting how the privileged groups are really less served by green corridors. They were looking at different cities, sort of big cities across Europe, from northern climates to further south, London included, and really highlighted that the vulnerability to climate change is exacerbated for low-income and underprivileged urban residents of wealthy European regions. So this becomes a really big issue wherever you are across Europe and the rest of the world. So as Gerald highlighted, cities are really these complex systems of interconnected links, sort of materials, buildings, open spaces, streets, sort of air quality. But against this very complex background, people really provide the common thread. So whatever happens in terms of environmental quality has implications for comfort, health, and well-being. And this is very much the perspective that I focus on with most of my research. The emphasis is on the people and the implications from the built environment. So what I'm going to present today, it's sort of a flavor of different projects and how some of these issues have been looked at in different parts of Europe mostly. I would like to start with a very big European project, quite old now, but really it was the first one that looked at the issue of urban comfort at larger scale. And what it really looked at, it's what's happening outside buildings, considering that buildings are not an island, and the space in between them very much affects what's happening in the open spaces as well as buildings. So we were conducting extensive monitoring campaigns in different cities, from Sheffield, Cambridge, the UK, Kassel in Germany, Fribourg in Switzerland, Milan in Italy, and Thessalonica and Athens in Greece, while conducting interviews with the people to understand the perspectives of the different environment and the use of space. And we collected a database of nearly 10,000 interviews across Europe, which we really needed this very big database to be able to conduct extensive statistical analysis and have robust results. So I won't go into details, but just to highlight a couple of issues. First of all, the big impact that the environmental conditions, not just the climatic conditions, but have the use of space. So very much around the microclimate that you create will have an impact, not just sort of in different seasons, but you know it will vary from different times of the day. So we have the daily as well as seasonal profiles. For example, in Athens, in the summer, which is on the left-hand side, it's the red dot, sort of use of the neighborhood spaces, and we're talking about neighborhood spaces rather than major touristic spaces here. Usage was quite low, and mostly the regulars sort of meeting up with the neighbors or the children to play in the small playground, whereas at the end of the day, after sunset, you really see the use of the space skyrocketing. And this sort of is the implication of the fact that it starts becoming much cooler outside than it is inside the buildings, when the buildings also start radiating the heat from the concrete. This changes very rapidly in autumn or winter when we have the reverse profiles. But this is not just in the UK. We see sort of the implications of the microclimate, the use of space in other cities across Europe. And this was an example from Cambridge, where you can see the same space and how the change varies in terms of the shading partners underneath in spring and then late summer, and effectively how the percentage of people in shade, you could even attribute it down to the average sort of air temperatures as they're increasing. Then another very important parameter was when we were actually asking people how they feel about sort of the thermal comfort, and they had to account for that in a 5-scale category from very cold to very hot. As you would expect, there is a normal distribution. And what was interesting was not so much what's happening in the middle scales, but what happens at the extremes. Now, if it was a direct link between cause and effect, you would expect that most complaints about very hot conditions would be in the hotter climates, such as Greece, and sort of Italy, perhaps, and most about the cold would be from Germany and Switzerland, where we had the colder conditions. But it is sort of very different. So, in fact, we had more people complaining about the heat in Switzerland or the UK, where people are not used to the heat, and vice versa. More people were complaining about the cold in Greece, where the winters were much, much milder. So there are different sort of ways to understand that, and I'm not going to go into details, but just to highlight, we have the capacity to adapt, whether through physical adaptation by changing our clothing, changing from sun to shade, or even by having a cool drink. In the context of urban design, physiology does not play a big part, but what becomes the most important is the elements of psychological adaptation. And this is where design actually can play an important role, from how natural a space feels, from people's experience and expectations, which would translate, oh, it's the summer, what do you expect? Or I'm from Australia, I'm used to the heat. Or I'm only sort of out here for 5 minutes, I don't mind the heat. So all these really influence our understanding and evaluation of the wider surroundings. So moving on to another project, much more recent one, was sort of a project funded by the EPSRC, which was around urban albedo, and really understanding not so much the impact of sort of a single material and the colors, but what happens when you have this urban mosaic, different materials, different colors, what are the implications for the urban albedo rather than the surface albedo of a single material. And in order to do that, we selected a typical housing area from Northern London, and we built a physical model at a scale of 1 to 10, just to highlight the scale. And we used real materials, so bricks, glass, so that it was as realistic as possible, and then tested the effect of different materials on horizontal as well as vertical level. So included the pavement, grass, and modern materials like aluminum cladding and curtain walling. And I'm not going to go through the details of the graph, but just to highlight the big impact that materials will have. So on a horizontal level, at this density, the horizontal surfaces have the bigger effect on urban albedo. And as you start, for example, increasing sort of the concrete pavement that have a lighter color, you increase the albedo, which means you have more light, solar radiation reflected, more heat ultimately reflected, whereas on the vertical facades, although they have a smaller impact, again, the different materials have a very big effect. And although if you look, for example, the effect of aluminum cladding or even curtain wall, the absolute numbers are very small. In terms of percentage, this is huge. So the reduction in the canyon albedo from brickwork, which is a typical material, to curtain walling is down to 45%, which means this heat stays within the area sort of where that we are exposed to, heats up the buildings with all the implications for the surrounding areas. And then we also developed a calculator that designers could use, urban designers, testing the effect of different geometries sort of, and different materials before publishing it at a guide for professionals through CIBSE. Another project looking at sort of transcending the silos effectively, vegetation, water, and sort of climate responsive systems, and how you can actually integrate them in the planning and urban design stage. So that was part of an industrial doctorate, the solutions for outdoor climate adaptation. And my team at Kent and Carlo Ratti Associates were focusing on climate responsive flexible systems, very much looking at it from the shading perspective and the needs for shading at the micro scale as well as sort of the city scale. So the two researchers working on that, for example, Sinead, she was looking at flexible system that responding to weather or microclimate change. shading is essential, but also shading needs are very extensively across the day, across the season. So how do you start optimizing about shading? And so really she was looking into developing a prototype, both in terms of materials as well as different times of day to optimize for shading at the micro scale, and testing the effect sort of in different areas with live examples and testing the usability. Another researcher was looking at the wider scale, at the sort of planning scale, working with a real master plan. So you have then, as all the municipalities have very sort of set budgets for shading, how do you optimize again? Where can you use, where do you put the shading that's going to have the biggest impact? How can you integrate natural shading from trees with artificial shading where the need arises? So that became a really important issue within a live master plan. And then really looking at developing sort of a prototype, if you want, for a tool for highlighting the needs, but also highlighting another very important need. We normally discuss thermal comfort models in very abstract, normally defined on the base of a male of height 1.8 meters, with sort of how much sort of time they need to walk across a space. The reality in our urban environments, though, is very different. You have people with walking assisted devices, you've got people in wheelchairs, you've got people carrying shopping. So all these have implications about how they experience the space and how much longer it would take them. So the needs for shading that a planner would work with would differ quite a lot. So it is important as part of inclusivity to address these issues. And one last slide I would like to highlight, going back to this sort of social equity component. In the project, one of my students was working many years ago, looking at comfort conditions in a similar climate, but very different sort of environments in Marrakesh in Morocco and Phoenix, Arizona. And I am not going to go through the details of what that meant for comfort. I would like to emphasize a single point that was consistent across both cities, and that is the bottom right-hand graph. So for people that are from lower socioeconomic background, the need for good open space is critical, because in all cases, whether we're in Phoenix or Marrakesh, these were the ones that would rely on the external spaces to provide cooling they couldn't get in the built environment. So consistently, they would spend longer amount of time in the open spaces as opposed to those from the higher socioeconomic background. So again, tying it back between those, the haves and have not, becomes really important in urban design. And so to wrap it all up, sort of, and considering as I would like to present thermal comfort as a commodity, we've discussed the interdependencies between different components of the urban environment, the buildings, open spaces, energy, microclimate. The list is endless. But it's also important to remember that the building form, it's a very important climate regulator. It is an important energy resource, particularly when we discuss sort of zero carbon buildings, but they are also the places where social interaction will take place. So important ingredients for a successful city, with implications for social equality and health and well-being. And that is why it's critical, this communication between the different disciplinary fields, whether it's architects, building services engineers, planners, sort of landscape architects, and health professionals, to really address these issues concurrently. Thank you very much. So I will stop sharing here.
Thank you very much. That was excellent. It's always nice to see the integration of the kind of experimental design and the modelling and the social aspects as well. So thank you very much. Satiris, would you like to start sharing? And
thank you, Claire. Thank you very much to you and Charles for the invitation and the privilege to share the online stage with Marialena and Gerald. Good afternoon all. I will try to be brief. I will provide the public health perspective to urban environments and climate change. which I think will build on the previous talks by Gerald, Marialena. I would like to start by acknowledging the traditional custodians and owners of the land where I work and live in Canberra in Australia, and pay my respects. I'm currently calling from Greece, where I'm on holidays. I would like to introduce very briefly the HEAL Center, the Healthy Environments and Life Center, which is coordinated by the University of Canberra in Australia. We develop a lot of research and translate research into policy and practice, aiming to improve health and well-being in urban areas and other places, and also to improve the sustainability and resilience of health services. We have many national programs in Australia, but our network has expanded internationally. And we have many projects and collaborations, especially in Asia and the Pacific, but also in Europe. And I will refer to some of the projects we have in Asia, as I've recently came back from a trip in Southeast Asia, where we launched two large projects on wildfire smoke and air pollution and health. Just to provide some context, so our work focuses on climate change and what we call the triple planetary crisis, which includes climate change, environmental degradation, and biodiversity loss. A lot of this work focuses on extreme events and the impacts on health and related adaptation and adaptation options, but also on slow burning issues, which are not necessarily extreme events, but have a significant impact on public health and the environment, including air pollution and overheating. The previous speakers covered overheating and to a large extent, so my talk will mainly focus on air pollution. I would also like to highlight that climate change mitigation is important and provides opportunities for public health. You can see here some examples, including active travel and the benefits from reduced emissions of greenhouse gas and air pollutants, and also opportunities for physical activity in cities. Other examples include healthier diets, which reduce emissions from agricultural farming, and improve diet and reduce the consumption of meat and saturated fats. And also household energy, rooftop panels, photovoltaic panels, improve energy efficiency, mitigate climate change and emissions of greenhouse gases into the environment, and also can provide improvements in terms of thermal comfort and efficiency. Urban green space, another great example of an intervention which reduces urban overheating and introduces opportunities for biodiversity and also for amenity for urban populations. And of course, access to health services that improves the baseline. It's good for health, it's good for the environment, and also if it is done in a sustainable way, can reduce emissions of greenhouse gases. So there are many examples of mitigation action that can improve sustainability, improve the environment and public health. In terms of air pollution, I would like to show this summary slide, which indicates that there are many pollution sources from urban areas, and more broadly, you can see here those highlighted: industrial pollution, traffic, natural sources, including forest fires, which is the focus of this talk, and the fact that the emissions from these sources contribute to urban pollution, but also to emissions of greenhouse gases like carbon dioxide and methane. And I would like to highlight also the feedback loop that you see on the slide. So greenhouse gas emissions obviously contribute to climate warming, and this increases the risk of wildfires by contributing to higher temperatures and drier seasons, which then make extreme bushfires or wildfires more severe and more frequent. This is highlighted in the article that you see here, and this gives an idea of the increasing frequency and length of wildfires across the globe. You can see here an increase in the wildfire season and also an increase in the length of the wildfire season. So I will refer to the extreme bushfires we experienced in Australia in 2020. This is an extreme case. So we had very extensive wildfires, which last much longer than usually. And these wildfires affected large areas of Australia, big cities like Sydney. You can see here the haze over Sydney. And also this is the Parliament of Australia in Canberra. So we have extreme levels of air pollution, PM2.5 in the hundreds, and the worst air quality in the world over a period of 6 to 8 weeks over that summer of 2020. And I would also like to highlight that in Australia, another important source of air pollution is wood heaters, which affect cities in southeast Australia, Sydney, Canberra, Melbourne, Adelaide, heavily affected by wood heater smoke in winter time. And you can see here some of these levels of PM2.5 in summertime with extreme wildfires, and in winter have the stagnated air masses, have a temperature inversion near the ground, and high levels of air pollution in winter mornings and evenings in places like Canberra, like in the pictures that you can see. So I would like, in terms of advances of technology, which obviously enhance our ability to monitor air pollution and monitor exposure, I would like to highlight the use of sensors, and we use them extensively. Some of these low-cost sensors can be fixed or portable, and they can provide real-time or near real-time information in terms of air pollutant concentration from PM2.5. And increasingly information about concentration of different gaseous air pollutants. Just to give a very quick overview, a couple of projects that we started recently. So this is a project focusing on community resilience centers. So I mentioned earlier, mitigation is very important, but adaptation is also an important component to our response to climate change. So we need to have means to adapt to extreme events, and the creation of resilience centers, like in libraries or other public buildings, has been proposed in Australia as a way of reducing the risk of extreme events on population groups in Australian cities. And this can be part of a response to a heat wave or an extreme wildfire smoke event. We can see here an AI picture which indicates what these public spaces may look like. So they might have sensors, air filtration systems, also catering and information, health information and advice on for different population groups. So we have a project now testing and evaluating this type of intervention, this type of community resilience centers in Australia. A couple of other projects, as I mentioned, I was in Southeast Asia just a few days ago. So we launched a Wellcome Trust funded project called Can't Breathe, which focuses on climate attribution of wildfire smoke impacts on priority population health in Southeast Asia and Australia. And we also, early in the year, we launched another project on wildfire smoke in Southeast Asia, focusing on classrooms, on schools, and adaptation options in schools related to air filtration and adaptation of the school environment to extreme smoke and heat, which is commonly experienced in the region. You can see here an overview of the two studies, of the two programs of work, with case studies in Northern Thailand, Laos, Cambodia, Indonesia, and Australia. Different environments, different types of fires affecting classrooms and households. And just a quick snapshot of the map with the fire hotspots in Southeast Asia. You can see here the extent of these wildfires, which are related to forest fires, but also agricultural and peatland fires. You can see here in Indonesia, many peatland fires. These pictures from Chiang Mai, northern Thailand. You can see here the fires which happen seasonally and the last 3 to 4 months, the beginning of the year. We have a lot of agricultural fires of rice straw in Cambodia, and these are peatland fires in Indonesia. So the concept of the project that I mentioned, the Can't Breathe project, is to do end-to-end attribution, starting from emissions modeling, fire modeling, and then climate chemistry transport modeling, estimating exposure of urban populations to key air pollutants. And this will be coupled with the sensors which are going to be deployed in urban areas. Some of them indoor, some of them outdoor. We'll focus on the classroom environment as part of the Hill Haze project and test different air filtration systems, sensors, and also early warning systems in these areas, and then develop a suite of communication and communication tools for different audiences and policy briefs. And I would like just to finish by saying that importantly, as part of these case studies and a lot of the work we're doing is we're trying to bring together different knowledge systems, including Western knowledge, science, and data with indigenous knowledge and lived experience of population groups living in urban areas, and some of them in socioeconomically disadvantaged groups. So we believe it's important to bring together these different diverse knowledge systems and learn from each other's experience. Please visit our website of the Hill Network if you want to have more information about the range of projects. We'll finish by acknowledging our collaborators in Australia and the wider region, and thank you for your attention. Over to you, Claire.
Thank you very much, Satiris. That was excellent, and thank you for keeping to time. So thanks all of the three speakers for very insightful and different perspectives on this broad topic. So our research theme is very broad. We have a number of questions, and if I can ask the speakers if there are any that in particular they would like to respond to. Otherwise, maybe I could start with a general one, and maybe someone could volunteer to share some thoughts. So there's a question about how developed countries have already experienced industrialization and are now focused on mitigating climate change. But developing countries have a further challenge of pursuing development while addressing environmental concerns. And this raises the question, how can developing countries find opportunities to grow more sustainably? I don't know if anyone would like to tackle that very huge question.
That is the core of the problem, is that the responsibility largely lies in the economically prosperous part of the world. I think the key is some form of knowledge transfer to allow them to jump over and some of the mistakes that we made in the past, and to make sure that the areas that we're building in the future don't lock in certain problems, such as, for example, types of urban sprawl that require enormous amounts of investment to simply maintain the system in operation. Now, I think there's a trade-off. I'm not entirely convinced by having extremely compact cities, but I think the key is to make sure that what we've learned from the cities in the prosperous part of the world can allow countries and cities outside that world to not make the same mistakes, but at the same time, of course, to allow them to develop. And that means genuine knowledge transfer and financial support.
Yeah, I think that is happening in a lot of places, that things are becoming more sustainable. Thank you. The next question that I see here, we're talking about cities having a major environmental impact on the planet. What would that impact be if the same population was residing in villages? Which is a very interesting question.
That's an interesting question. Of course, this is a it's not going to be the case. 60%, 70% in the future of the global population will be living in urban areas. I think there are benefits to that, and an urban form, urban density can have positive impact on climate change and greenhouse gas emissions, so densification, if it's done properly. Low carbon urban development can provide benefits in terms of energy efficiency, in terms of access to services. So there are many benefits to urbanization if it's done properly, and we've seen these benefits realized in certain cities. But of course, the other side of the coin is that there are many unsustainable cities and places where where development is not it's not a low carbon development. It's a development which follows a pattern of overconsumption and over emissions of greenhouse gases and air pollution. So I think we can learn from the best examples globally, avoid the mistakes of the past, especially in low-income countries, and encourage low carbon urban development. I think living in villages is not an option, obviously, and I wouldn't think that it will necessarily lead to healthier or more sustainable lifestyles.
Mm. Thank you. Yeah, Marialena, please go ahead.
Yes, exactly, to highlight the same points that Sotiris mentioned. We're talking about sort of density is needed because you can provide the job opportunity, all the other opportunities that people come to cities for, and also the infrastructure networks. We don't want to start developing similar infrastructure sort of at smaller scale. So going back to Sir Gerald's points as well about urban sprawl, we have to be careful. I mean, you could argue that sort of growth, development, and sustainability cannot really go hand in hand. So we need to be careful, but learn from successful examples and avoid repeating the same mistakes. It's an important point, and avoid development just sort of in terms of what we see in terms of urban development, specifically importing models that were developed in sort of the Western world, irrespectively of wherever you are in the world, sort of whether you are in an Arctic climate, a tropical climate, you end up with the same and identical, actually, design response for buildings. Clearly, this is not sort of the best way forward, and we really need to learn from our mistakes very soon before it's too late.
Thank you. So next question, I'm going to paraphrase Hector's question. It's because it's a little bit long, but basically he's asking, is there also research looking at how climate is changing outside of cities, so in rural areas, and how any interventions in cities might affect rural areas, thinking about ecosystems and kind of broader environmental feedbacks in rural areas? I don't know if anyone has any thoughts on that.
I can mention obviously the impact fires have in urban and peri-urban areas. So many of these fires now are happening in the periphery of cities. As I mentioned in my presentation, from wildfires, forest fires, agricultural burning, waste burning, which is a big issue in many parts of South Asia and Sub-Saharan Africa. So there are many aspects in rural areas that affect cities, and of course, as cities are growing, they're encroaching on green spaces and space outside the core of the city. So what's happening in rural areas and peri-urban areas is going to affect urban development. It's going to affect urban health, and there's a continuum there. And of course, when we think of air pollution, it travels long distances. It doesn't recognize borders. So of course, we need to mitigate air pollution at source, but also adapt to air pollution overheating in urban areas where people are exposed to these extremes.
I'd also say that in conventional sustainability terms, cities are not and cannot be sustainable, simply because the definition of a city is that its landscape is used almost entirely for human actions, but not for the production of food. So clearly cities rely on their hinterlands, and that means there's a very, very close relationship between the two. I don't know, there's a city in the world that doesn't require water gathered in rural areas in order to supply the drinking quality water of cities, or, for example, as was spoken about, the effects of forest fires, which generate pollutants then come into the city. So the two things are intertwined. It's just that if you take a purely anthropogenic perspective on the world, then it's a city-based perspective.
And maybe we're running out of time a little bit. There's a question specifically about schools. I know there's a few projects at UCL looking at that are going to start looking at net zero and resilience in schools, but maybe of any of the other. Yes, Marialena, I think you've worked with schools.
Yes, yeah, we have actually a new project that will be starting the 1st of September, most probably, very much looking at these issues in terms of schoolyards. So we're really going back to this sort of aspect of thermal comfort models developed based on the MAIL of 1.8 sort of meters, etc. So very much looking at developing outdoor thermal comfort models for children and focusing on developing design guidelines for the schoolyard. So we'll be looking at different schools across the UK, from inner city areas where the problems of urban heat as well are more critical, and looking at adaptation measures. And this is a large team of us, different universities with Brunel, Loughborough, Portsmouth, and UCL will also be involved, and very closely with the Department for Education. So hopefully in 2-3 years' time, we'll be able to report back on that. So watch the space, I guess.
Fantastic. That's great. And I think we're just about out of time. Thank you so much to the speakers for an excellent, really enlightening session. I hope everyone has got something from all of these diverse talks. And thank you for your questions. I'm sorry we didn't get round to all of them, but thank you very much to everyone for joining. I'll say goodbye.
Thank you very much.
Bye-bye.